Okay, period 4, 5, and 6, Algebra 2. We are going to work on Chapter 6. This is where we pick up now. If you guys could do this for me really quick, look at the whiteboard on the far left. I have the Chapter 14 test. Students that have not taken it from period 4, 5, and 6. Please try to get with me today somewhere around, well, I should be in my classroom from 2:30 to almost 3:30. So if you could get with me, I need to get this stuff done and corrected and in the books. Quarter 3 ended last Friday. I don't think I need to get my grades done until Tuesday, 4 o'clock. So I need to talk to you. Please show up or tell Mr. Kuntz the story, and it better be good. Okay, before we start this lesson, please take out a sheet of paper. Hopefully Mr. Kuntz has already told you to do this, but on the far right side of the whiteboard, I have all the perfect squares, perfect cubes, perfect fourth and fifth powers. You will need to know that in Chapter 6. Chapter 6 is loaded with square roots, cube roots, fourth roots, fifth roots, okay? Okay, so here's the lesson. Mr. Kuntz is probably giving you the note packet, and let's begin. All right, before I begin, let's start here. If you are given a power problem, this is a power problem, 3 to the second power. The number 3 and the number 2 are called something. I'm sure most of you could probably get this one. This one is called the base. Okay, the 2 is called the exponent. Okay. All right. Now, what the power problem tells you is take the base times itself twice. So the answer would be 9. All right. And I'm sure that doesn't surprise anybody, but you will be going backwards today. You will be saying, what's the square root of 9? And your job is to tell me 3 times 3 is 9. Okay. All right. Now, with that little background, let's try to answer this question. Parts of each expression below are in blue. Here's blue here, and blue here. Okay? All right. Write B if the base is blue, E if it's an exponent or is blue, or N if neither a base nor an exponent is blue. Okay. Hopefully you can pause it and just answer the questions and then turn it back on. Okay? By now, I'm thinking you turn it back on. 54 is known as the exponent. I'm going way over here now. W, because it's W raised to the second, W is called the base. The number 2 in this one, it is not the base. It's not being raised to the second power. It's not the exponent. What we would say neither to this one, but maybe you should write this. The number 2 in front of R is called the coefficient. Okay, so that's a word that we've talked about many times. It's not the base, it's not the exponent. Okay, all right, that's just a brief rundown of exponents and bases. Okay, when we talk about square roots, cube roots, this is what we're really talking about over here. Okay. It says over here, these are the words you'll be hearing in this chapter: square root, cube root, nth root. You'll hear power, radical, index, radicand. Okay, so here, 3 of those words are right over here. The root you're looking for, if you're looking for the square root, cube root, is called the index. Okay. The number inside, well, let me talk about this. The word radical is really the symbol for square root. The number inside the square root or the radical is called the radicand. So it is very important that you understand the wording because they're going to ask you questions. All right. Here's a quick definition here. The nth root of a given number is a specific number that, when it is used as a factor n times, equals the given number. So, for example, okay, this one is the what root? The cube root of what number? 8. And remember, 8 is called the radicand. And I'm asking you for what number times itself 3 times will give you 8, and the answer is 2. So if you come back here, guys, they kind of told you that 2 times 2 times 2 is 8, so that's why that's the answer. Okay? All right, continue down, go go draw lines to the right number. Again, pause me. Give yourself about 5 to 10 seconds. Hopefully it's as easy for you. And then start me up again. Okay? All right, you're probably done. Here we go. Hopefully this symbol you understood was called the radical symbol. The square root, cube root symbol is a radical. Okay? What root are you looking for? You are looking for the 4th root. But the 4th root is known as the index. Okay? The number inside the radical, inside, right here, 81. 81 is called the radicand. It's the number you're trying to find the square root of. And the number 3, right here, is known as the square root of sorry, I didn't mean to say square root. I meant to say 4th root of 81. So yes, here we go. That's the root. Okay? And it should make sense because 3 times 3 times 3 times 3 is 81. There. These are radicals. We're just talking about radicals. Okay. Now this bottom part, I'll try going fairly slow for you just so you can kind of understand the terminology here. All right, here we go. It says if a to the n is equal to b, and a and b are real numbers, that means any number, and n is positive, a positive integer, then a is the nth root of b. Okay, and that's probably a little confusing, so let's reword that. Let's say this, instead of a to the n equals b, let's say 3 to the second equals 9. Okay, now if you did that and you reread this, if a and b are real numbers, here's a, here's b. They're real numbers, and n is a positive integer. Okay, yeah, that's a positive integer. All right, then a is the nth root of b. So I'll just write this out. Then a, which one's a? 3 is the nth root of b, is the square root of 9. Now, hopefully that made sense. To me, reading this little saying here, all this is a little confusing, but if you put the numbers in, it makes a lot more sense. Okay, now, you are going to be asked all day, in your assignment, if n is odd or if n is even. Now, to me, the one that's pretty easy is the odd. So what they're saying is, if n is odd, if your root, if you're looking for a cube root, that's odd. If you're looking for a 5th root, that's odd. If n is odd, there is one real nth root of b, which just means there's only one answer, denoted in a radical form as the nth root of b. So what I'm asking you to do is give me the cube root of 64. Well, look at your little table that you wrote down right at the beginning of class. What is the cube root of 64? Well, I think you can see over there it's 4. 4 times 4 times 4 is 64. Okay, and since there's only one real nth root, it's going to be just positive 4. That's it. 4 times 4 times 4 is 64. Okay, let's do this one. Or the 5th root of 32, negative 32. Well, you should know just by looking at your table. 2 times 2 times 2 times 2 is 32. So we have negative 32. So our answer is going to be not 2 times itself 5 times, but negative 2 times itself 5 times. And if you kind of just wrote it out, you would see that 5 negatives, negative times negative times negative times negative times negative, is negative. 5 negatives, odd number of negatives is a negative. So the answer is negative 2. Okay, next. So I don't think that was the hard one. I think the next one you have to be very careful. If n is even, if your root is even, square root, 4th root, 6th root, then you got to be careful. If it says here, if b is positive, there are two real nth roots of b. So without reading, I'm just going to do the next one. If b is positive, look inside here, right there, and you are looking for an even root too, then they're telling you the answer is going to be 10 times 10 is 100. Also, negative 10 times negative 10 is 100. Okay? I don't think I'm going to read the rest of it to you. You can read it. This next one says, let's find the fourth root. Fourth root is even, and since the number inside is positive, there are going to be two answers. And if you look at your table, 16, it would be 2 times 2 times 2 times 2 is 16. So is 4 negatives. 4 negative 2's would also be 16. So this is why you're getting two answers. So when you have an even root of a positive number, you get two answers, plus or minus. Okay, but hang on, because it gets tricky. It says if b is negative, so when the radicand is negative, and you're looking for an even root, well, I think if you just think about it, positive 10 times positive 10 is not negative 100. Doesn't work. Negative 10 times negative 10 is positive 100. Doesn't work. So there are no real roots. So we would say no solutions. Okay? Somebody out there might be thinking, wait a minute, isn't it going to be plus or minus 10i for imaginary numbers? You are right, but they said real. No real answers. There are imaginary, but we're not going to talk about the imaginaries. Not in this chapter. Okay. Okay. Pause me. Answer the next question. Number 5. Just pause me for whatever, 10 seconds. All right. Now that you pause me, underline the correct words to complete the sentence. Since the index of the fourth root of 81 is, well, it's 4. Even, and the radicand is 81, and 81 is positive, then there are how many answers? Well, even roots of positive numbers get two answers, two real fourth roots. Okay, so then the fourth root of 81 is, and if you're looking at your table, fourth root looks like 3 and negative 3. Okay. Now, I think the rest of the notes go pretty fast. So let's just kind of turn the page and start. All right, so the next page. Okay, we want fifth roots of each number. I feel like I forgot something. Can I go back? I want to go back. Okay, go back. And I forgot one thing. It's right here. Right here. Let's go right there. What is the only nth root of 0? Well, I don't care if you take square root, cube root, fourth root, fifth root, you're still going to get what? 0 every time. Okay, now let's move on. Find all real fifth roots of each number. Well, fifth root of 0. We just talked about it. 0 times 0 times 0, 5 times is 0. This one, fifth root of 32. Well, look at your chart. 32 looks like the answer is 2. Is it plus or minus? No, this is a fifth root. Fifth roots get one answer. Since 32 is positive, it's positive 2. All right, the fifth root of what? Negative 1. Again, fifth roots get one answer. Negative 1. What times itself 5 times is negative 1? Happens to be negative 1. Okay? The fifth root of 1 is 1, and since it's negative, it's going to be negative 1. Okay? And you can check any of these. If you want to check them, just kind of, you can write them down, type it in your calculator, or just kind of think that one out. Yeah, 5 negatives would be a negative 1. Okay? All right, next, we want the what? All the real square roots. Well, square root is even. We're talking this. We don't ever put the two, but that's what you're talking. And when you have even roots of positive numbers, you get two solutions, plus or minus. Okay? All right. Just then, when you look at this, the number 36, you should know that 6 times 6 is 36. But I don't have 36. I have 0.0036. Now, you could kind of guess it. You could say, is it 0.6 times 0.6? And you'd find out that's wrong. But then I would go, what about 0.06 times 0.06? And then you could plug that in or type it in, and you'd find out you're right. Okay? Or the other way is just type it in your calculator. What is the square root of 0.0036? And it would tell you that. But what your calculator won't tell you this right here, plus or minus. Okay? All right, let's do the next one. The square root of negative 1/64. All right, first of all, square roots get two answers if the number inside is positive. Well, because this is negative, there are no answers, so you just say no solution. This one, square root of 49 over 144. Square root, these numbers inside, look, they're both perfect. Square root of 49, 7. Square root of 144, 12. The answer is 7 twelfths times 7 twelfths. But don't forget, also negative 7 twelfths times negative 7 twelfths works too. Okay? Okay. Find each real root. Be careful. Here they want cube root. Here they want fourth root. Here they want square root. And here they want square root. Okay? Okay, so if we want the cube root, I'm sorry, I didn't have to write this again. If they want the cube root, there's only one answer. And you know 3 times 3 times 3 is 27. But because it's negative, you have to say negative 3. And again, it should make sense. Negative 3 times negative 3 times negative 3 is negative 27. How about the fourth root of negative 81? Because this is even, there should be two solutions. But look inside, it's negative. If you've taken the fourth root, even root of a negative number, it doesn't work. There are no solutions to this problem. Okay. Okay, this time you're taking the square root. An even root. But is the number inside negative or is it positive? Well, if you do the inside first, negative 7 times negative 7 is positive 49. So really this question is saying, what's the square root of 49? Plus or minus 7. This one says, what's the square root of negative 49? You can't take even roots of negative numbers. Hopefully I have said that enough. Now you know. Okay. I think we're making it. We're almost there, guys. Next page. Okay. Oh, now the variables come. Now, because the variables are here, maybe off to the side in the margin, you want to just practice a couple before we start. Okay, so here's what I did. If you get variables, this is just a quick mini lesson on variables. If I said, give me the square root of x squared, well, I think many of you would say, oh yeah, x times x is x squared, right? Whoops, x times x is x squared. So that works. X is your answer. But what if I give you x to the fourth? What's the answer? Well, I'm hoping you understand that this is just x squared times x squared. That's what that really is. And since the square root of x squared is x, and the square root of x squared is x again, really, this is what you're getting. You're getting x squared. Okay, and if I continue this little process, x to the, let's say, 6. Okay, well, you have to kind of think of it as, again, x squared, x squared, x squared. Okay, and each one of these, square root of this, square root of this, square root of that, is x, x, x equals x cubed. Now, sooner or later, you're going to figure this out. When you take the power of the radicand, 6, and you take the index, 2, if you just take the 6 and divide it by 2, you're going to get the exponent of the answer. So if I were to do this to you, the square root of x to the 12, I would hope you would say x to the 12 divided by 2, 6. And I hope this would make sense. X to the 6 times x to the 6 is x to the 12. All right? Now, what happens if this is not an even power? That's the trick. A little tricky part, I should say. So what if I go like this? X to the 7th. What are you going to do now? Well, here's what you try to do. You try to make it a number, a power that is divisible by 2, like x to the 7th. Well, let's make it x to the 6th times x to the 1st. This is really just x to the 7th. Now, what's the square root of x to the 6th? 6 divided by 2 would be x cubed times, can you take the 1 and divide by 2 and get an even number or an integer? No, you can't. So 1 is not divisible by 2, so you don't know the square root of x, so you leave that one inside, and this becomes your answer to this kind of problem. Okay, what if, just really quick, what if it's a cube root? What's the cube root of x to the 3rd? Well, 3 divided by 3 is x to the 1st. What's the cube root of x to the 15th? 15 divided by 3 is x to the 5th. Now here's the tricky one. What's the cube root of x to the 17th? 17 is not divisible by 3. So you rewrite it, cube root of. Now pick a power of x that would be divisible by 3. Well, I would just go down to 15 and make this a 2. All right, this times this is really just x to the 17th. X, the cube root of x to the 15th would be x to the 5th times, because 15 divided by 3 is 5. And this is 2 divisible by 3? No, so just leave it in there. Cube root of x squared. And there it is. All right, that was a mini lesson. I hope that made sense. And now I'll go answer your questions back here. Okay, ready? Square root. Even root. Even roots get 2 answers. Oh, time out, sorry. I'm sorry. Here, would you read this? Assume that all your variables are positive. If that's what they're saying to you, they're just trying to tell you that whatever you put in for x, it's going to be positive, which makes the radicand positive. So you can't say no solution to any of these. So don't say no solution, okay? All right, you ready? Square roots get 2 answers. Square root of 81 plus or minus 9. All right, square root of x to the 4th. Well, the power 4 divided by the index 2 is x squared. That's it. Next. Square root of 25. It's an even root, so you're going to get 2 answers, plus or minus 5. 2 divided by 2. Oh, that's just a to the 1st. B to the 7th. 7 is not divisible by 2, so you know what I would do? I would change it to, I'd go like this. B to the 7th is really just B to the 6th times B, and then just cross that out. What's 6 divided by 2? 3. What's 1 divided by 2? It doesn't divide out. It doesn't become an integer, so I'm going to leave it in there. Square root of B. There you go, guys. That's the answer. I know that's ugly, but that is the answer. Okay? All right, next, the third root. What's the third root of all this? Well, remember, odd roots get one answer. Don't say plus or minus. Only one answer. Okay, so it's going to be 12 divided by 3, p to the fourth, 6 divided by 3, q to the second. There you go. That's it. Don't say plus or minus because that would be even roots. Here's an even root. 2 solutions. Plus or minus something. Well, 8 divided by 4 is p to the second. 4 divided by 4 is q to the first. Plus or minus p squared q is the answer. Okay? A quick story problem. And it's not even a real story problem. It's just, they're just giving you a formula. You're supposed to use it. It says, some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores would be A equals 10 times the square root of R, where A is the adjusted score. Just let you know what this is, adjusted score, okay? R is the raw score. The raw score is actually what you got on the test. The adjusted score is what the teacher's doing, trying to be nice to you. Okay, what would be the raw score to the nearest whole number for an adjusted score of 80? Well, if you have an adjusted score of 80, you probably would put it here. 80 equals 10 times R, square root of R. Solve for what? I would get the square root of R all by itself. So divide by 10 and 10, and you get 8 equals square root of R. We haven't done many of these, but how do you get rid of square roots? Well, the opposite of squaring something is square root both sides. If you're going to square root your variable, the opposite would be take it and square it. Okay, you're going to get what? 64. And what is the square root of R times the square root of R? Well, that's the square root of R squared, which is just R. Okay. This is your raw score. You got a 64 on the test, and your teacher gave you a what? 80. That's the adjusted score, but what we were looking for was the raw score. And that's the answer. That completes the lesson. Take out your book, start the assignment. Mr. Kuntz, can you give them a calendar to go with that? All right, good luck, guys. We'll see you 2:30 for those who have to make up Chapter 14 test. Otherwise, I'll see you tomorrow, Tuesday.